don't see my picture there. Hello, pre-algebra. Let's do this. Let's go. Let me just, oh, there it is. Hello, pre-algebra students. Mr. Soto here. And I just want to let you know this is how we're going to be doing things for a while. And so we're going to, if you can turn that volume down on that, just so I don't get feedback on that. And we're just figuring this thing out. Sorry about that. Just changing some things up. We're going to do 6 lessons here, 84 to 86. And that'll be a week and a half worth of teaching for you, because we do 2 each time we meet on Tuesdays and Thursdays. And so let us go ahead and get rolling here. So we want page number, lesson 84, which is 84.1. So they kind of taught us a new way to do things. I've already kind of taught you this way, and we're going to do this very, very easy problem here. We know that x plus 5 equals 7, so we are smart enough to know that x has the value of 2, because 2 plus 5 equals 7, and we know equals means the same on both sides. So 7 equals 7 is how we roll on that. So when it's this easy, we know how to do it. And let me get my eraser. I think it's back over here. We were working on getting this all set up, so I kind of wasn't ready for us. But now I'm getting ready. Hey, have no fear. So I've kind of already showed you that in order to find the value of x, we get x by itself. And so we do the inverse operation of x plus 5 equals 7. So I subtract 5 from this side to get x all by itself. These are things I've already taught you. This cancels out. I realize you don't have to actually do this step, but it is good to do it just so you can keep yourself consistent. Anything you do to one side of the equal sign, you must also do to the other side of the equal sign as you are rationalizing this equation. So x equals 2, because 7 plus a negative 5 or 7 minus 5 equals 2. This is very easy. You can do this in your head. I'm showing you how it's done, though, on this particular problem. So let me get you a harder one. Next one, 84.2, is the next one. And there's actually a couple steps here. And you can look at that on your book if you'd like to. We're on page number 263, 84.2. And we have fractions here. And we have unknown value of x. So we're going to solve for this value of x. And so the first thing we want to do is get x all by itself, all by herself, all by himself. The reason I do this is I want to get this 2x by itself, and then I want to get the 2x away from each other. But this is first steps first. So I can now drop this down, and I have the equal sign there. A half minus a half cancels out. The reason I chose to subtract a half is because this is plus a half. Inverse operation of addition is subtraction. That cancels out. Anything I do to one side of the equal sign, I must also do to the other side of the equal sign. We have the fractions here, though, so we have to actually have common denominators. So let's make this a 4. Make this a 4. Okay, so 2 goes into 4 2 times. 2 times 1 is 2. And this just stays the same. So I've rewritten this fraction here, so I'll cancel that out just because I've rewritten the fraction. So I have 3/4 minus 2/4. 3 minus 2 is 1. The 4 is the denominator stays the same. So I've taken the original problem, 2x plus a half equals 3/4. I've subtracted a half from both sides because the inverse operation of addition is subtraction. Now I have 2x equals a 4th. Now, this is where it gets a little bit, you got to really pay attention to what's going on here, something new. What I'm going to do is the inverse operation. Anytime you have a number next to a letter, the implied operation that is there is multiplication. So you have to do the inverse of multiplication, which is division. So we want to divide by 2. Now watch how I divide by 2 here, okay? So this is already a fraction, but then I use a little bit larger of a division bar there, or a fraction bar, if you will, by 2. Now this, watch how over here I divided by 2 because I want to get the x all by itself. This is 2 times x. Inverse operation is 2 divided by 2. It cancels out. Now I have x all by itself. And so, but here, a little bit tougher, I'm going to put that 2 over 1, and I'll show you why. Because I have 1/4 divided by 2 over 1, and we have we got to do the reciprocal of that one, right? Because anytime you divide by a fraction, you do its reciprocal and multiply. So we'll rewrite this like this: 1/4 times 1 over 2. Okay? So now we have, this is canceled out. I have x all by itself. I have a fourth divided by 2, or 2 over 1. I rewrite it this way because it's a little bit easier. I now flip it, do its reciprocal, 1/4 times 1/2, and 1 times 1 is 1, 4 times 2 is 8, and our answer is 1/8. Now, if you multiplied 2 times 1/8 and you added a half, you'd get 3/4. So you can always plug this back into this problem right here. Let me go on to the next one, and let me call my son real quick. Samuel, are you out there anywhere? If there's any way we can make sure that there's volume on this, because I hate to be doing all this and it not be having volume. Let's go on to the next one. I miss you, class, by the way, and all kinds of great things happening in our, by great I mean just serious things happening in our country, so this is a good way to get together, connect, and we'll try to do this for the time being. So now I'm going to go to 84.3, and we will solve this. A little, not quite as hard, I don't think, as the previous one. I'll show you how it works, though. It's a negative 3x equals a negative 12. This is 84.3 on, 84.3 on page 264. All I have to do here is this. I could do this one in my head, and so could you, because you're smart enough to do this. A negative 3 times what equals a negative 12? Well, we all know a negative times a positive equals a negative, and 3 times what equals 12? 4. So we know how to do that in our head, but I want to show you how to do it. I'm going to divide both sides by a negative 3. The reason I divide both sides by a negative 3 is because I want to have an x value positive all by itself, and that's my answer. So a negative 3 divided by negative 3 is a positive 1 over 1, which is just 1, which is just x. So now we've gotten rid of that. That's just x. And we've separated it. This implies multiplication. Inverse of multiplication is division. Anything I do to one side of the equal sign, I must also do to the other side of the equal sign. These negative signs just cancel each other out. A negative divided by a negative, or a negative multiplied by a negative, is a positive. 12 divided by 3 equals 4. There's my answer, x equals 4. So let me go on to the next one. And we're going to get rolling here. Let's go to 84.4. I have a negative 3x plus 4 equals a positive 10. Okay, again, this is not as difficult. That second one's the most difficult one we've done. But we'll do a couple of practice. I know there's one like that as well. So here what I want to do is I want to get the x all by itself. And so whenever I get the x all by itself, the first thing I need to do is get rid of this 4. It's a plus 4, so I have to do the inverse of that, which is subtraction. So I'll subtract 4. That's getting rid of it on the same side of the equal sign as the x. Anything I do to one side, I must do also to the other side because of the equals. And so that cancels out. Now I have negative 3x equals a positive 6, right? Because 10 plus a negative 4, or 10 minus 4, is 6. And it's positive. So now I have a negative 3x equals 6. I'm going to divide both sides by negative 3. Again, why do I divide both sides by negative 3? Because I want this x all by itself. And when I get the x all by itself, I have my answer. So negative 3 over negative 3 just cancels out. And so now I have the x by itself. And now I have 6 divided by a negative 3. Now I've told you before, you can't have an answer with a negative denominator when it's all said and done. But while you're working a problem, you can leave that there as you're rationalizing the problem. 6 divided by a negative 3 is 2 negative, because there's an odd number of negative signs. 6 divided by 3 is 2. There's an odd number of negatives, so your answer is negative 2. Again, you can always plug this back in. A negative 3 times a negative 2 is a positive 6. Positive 6 plus positive 4 is 10, and 10 equals 10. That's how you check your work. You know your answer is correct. Okay, so there's some properties there, and just kind of the things I've taught you already. You can look at 84.5 and commit to memory those inside that box there, the properties of equality. But let's do A and B on, I want you to try to do that. And Max, you can't do it in your head. Get your piece of paper out, and we want you to do that problem. And anyways, here we go. Enterite cruise. Are you paying attention? All right, here we go. So we have negative 2x. This is A. And plus 5 equals 9. All right, you got to pause your screen, and you got to try to do it. And then when you are done, push play again, see if you got it right. All right, so we're going to subtract 5 from both sides because we want to get x by itself. Anything you do to one side of the equal sign, you must do the other side of the equal sign. We subtract here because it's the inverse operation of addition. That cancels that out. 9 minus 5 is 4, positive. And negative 2x equals 4. This negative 2x just drops down. We divide both sides by negative 2, divide both sides by negative 2. This cancels out. I have x by itself. 4 divided by 2 is 2. And we have an odd number of negative signs, so my answer is negative 2. You can always plug this dude back in here. A negative 2, which is x, times the negative 2 that's outside of x is a positive 4, because the negative times the negative is a positive. A positive 4 plus a positive 5 in the original problem equals 9, and 9 does equal 9, so we know that that is the correct answer. All right, letter B. Why don't you pause your screen and try to do letter B. Once you've done it, you may press play again, and we will... did you pause it? I'm not going to do all your work for you. You got to do your own work. So you got to try it, press pause, and I saw you didn't press pause. And so we have letter B as negative 3x plus, this is a little bit tough one, like we saw on the original the second one we did on the example. So here what we're going to do is we're going to have to get the x all by itself. So the first thing to do is get rid of the half. It's a plus half, so I have to minus a half, inverse operation. I minus a half here. But I have to have common denominators, so let me rewrite that with common denominators. And it's minus. Now this is a little tough, and this is a minus sign right here. We can put it right here. Okay, so I have 3 minus 4. That's actually negative 1. Is that correct? Because 3 minus 4 is negative 1 over 8 equals, this cancels out, negative 3x. Now there's something you can do, and maybe a little bit easier. You can actually multiply both sides by a positive 8 to get rid of the fraction. But they haven't taught you that yet. But if you know how to do that, I don't mind you doing that. I'll do it this way. I'll do it the other way just to show you how it works so you know. And but here we're going to divide both sides by negative 3. When I do that, that cancels out. I have x by itself. I divide both sides by 3. I'm actually going to express this as 3 over 1 because any number that's a whole number can be expressed as a fraction over 1 because that's how all whole numbers work. So I can write it this way to see it more like we did a year or two ago in previous maths. So I have negative 1/8 divided by 3 over 1, which is also divided by a negative 3. That's a negative there too. Negative 3 divided by negative 3. So now the negatives cancel each other out. I don't have to worry about them anymore. All right, so now we're to whole numbers, positive numbers. Remember here, 3 over 1 divided, you invert it, and you go, so 1 times 1 is 1. 8 times 3 is 24. And we have x equals 1 over 24 positive. Those negative signs cancel out. The 2 negative signs here you had cancel out. 1 times 1 is 1. 8 times 3 is 24. Now, I'll show you how to do it really quickly on the multiplying everything by 8. And we'll get the same answer, which I'll write here, which is 1 over 24. And so I had negative 3x equals 1/8 negative. Okay, so what I'm going to do is I'm going to multiply both sides by 8. Watch what happens. The reason I do that is because that denominator is 8. This is just another way to do this. And to me, I believe it's a little bit easier, although I haven't taught you this yet. So when I do that, I go ahead and cancel that out, and that becomes a negative 1. And again, I chose 8 because it'd cancel out that denominator. So I chose the denominator, the least common multiple here, which is, there's only 1, so it's just 8. Now watch, I divide both sides by negative 24. X is now all by itself. Negative signs cancel out. These negative signs also cancel out, and I get the same exact answer, x equals 1 over 24. Either of those ways suffice. That's the toughest problem we've done today, and a good job on that one. All right, let's go on to 85. And lesson 85, you can try 84. And if you get some questions along, I'll do some problems for you. And 85, and we're actually going to be using some quadratic, well, they're not really quadratic equations, but the graphs here that we've learned about. And so let me show you how to do this. 85.1 on page 267. Okay. It gives you an equation. Y equals x minus 2. Okay. So what we're going to say is this. In order for something to have equals, it means it has the same value on both sides of the equal sign. That's what equals means. As I told you before, when you were younger, they told you 1 plus 1, they want you to go 2, but it's not 1 plus 1 equals 2, it's 1 plus 1 is 2, and 2 equals 2. It's the same on both sides. So, okay, I'm going to put x on my left and y on the right and make a little column here. I'm going to choose 3 different values for x, and I'm going to choose, and it'll solve for the values of y. Now, as you get into these, when they get more complicated, you can sometimes say, I want to choose a value for y to solve for x, and you'll sometimes need to be creative because you want to stay away from any decimals or fractions. This is still relatively easy. So one thing you can always do is you can always start with 0, right? If x equals 0, so I've chosen the value of 0, me, Justin Soto. If x equals 0, 0 minus 2 equals negative 2. That means y equals negative 2. All I've done is taken this value that I've chosen, plug it into the equation, then I solve for y. If x equals 2, I'm going to take that 2 that I chose, put it here, and 2 minus 2 equals 0. That means x or y equals 0. So now I can choose any number, and let's say I could choose 1, 2, 3, 4. Let's just say 1. Let's say 3 actually. So if I choose 3, 3 minus 2 equals 1. Okay, so you can choose any value you want to. The book probably chose different values unless we just so happen to choose by coincidence the same values. Okay, so now I'm going to plot these. Remember, this is the x, this is the y. Okay, this is the x plane, this is the y plane. And so here we'll go x equals 0, y equals a negative 2. I'm not drawing all my hash marks. I think you can figure out that's about negative 2. Now I have 2, x equals 2, y equals 0. And now I have x equals 3, so I go 1, 2, 3, y equals 1. What this will always do on an equation, unless there's like square roots or absolute values, which we're not going to do till next year, it will always create a straight line. For example, if I put these arrows on either end, because those lines go on forever. And because those lines go on forever, you could choose the number 100, for example. Let's say you wanted x to equal 100. 100 minus 2 is 98, right? So if you take 100 for x, plug it into the problem, and then you solve 100, because that's what you chose, minus 2, that means y equals 98. If I were to be able to go all the way over here to 100 this way, and way, way up there to 98 that way, it would fall right in line with this line right here. And so that's what you're doing here in this particular one. And they've chosen, again, different values. You can choose whatever you'd like to. Practice, basically the same thing, except the problem is just a little teeny bit different. So why don't you press pause? Why don't you create, let me tell you what to do before you press pause. Write down the practice, which is y equals x minus 3. And then you're going to do a little graph like this. Always do x first and then y. And because x is the first one that you plot on the parenthesis bracket that you've learned before, x and y. So you want to go x and y, even though here it just so happens they're backwards. And that's okay, because you'll see it with x on the other side. And sometimes you'll see x and y on the same side. So there's all kinds of different things that you could have there. So do x, y, choose 3 values, plug them in to the original equation, then plot them on your graph here, and press pause, and you try that. I said press pause. All right, here we go. AJ, are you paying attention? Of course, I am Mr. Soto, and all right. Are you back? Perfect. Let me see if you got it right. We're going to choose 3 values for x, and I could choose 1. You could have chosen 0, 1, 2, 3, all kinds of numbers, but 1 minus 3 is negative 2, or 1 plus negative 3 is negative 2. I'm going to choose 3 also, and 3 minus 3 is 0, and I will choose 4, just so I have some positive x's here. And 4 minus 3 is 2. So I've chosen those 1, 2, 3 values. You could have chosen any values that you'd like, but the fact that you chose, doesn't matter what values you chose, they're going to end up on the same exact line because it always works out that way, if you did it right. You have 1 over 1, negative 2. You have 1, 2, 3, 0. And you have 1, 2, 3, so, and although my graph's not necessarily perfect, those points should actually... It should be about right there is what it should be, like that. And so your line should be going through here with this little triangle portion there, have arrows on either end. And so that is lesson 85. And let's go on to lesson 86 and see if we can... Okay, 86 is basically algebraic phrases. What you're going to have to do is just commit some of these to memory. I want you to go through and read all those phrases. And for example, it says the word phrase, the sum of a number and 7 is n plus 7. The word sum means an addition problem, so it says the sum of a number and 7. So and means obviously plus, so the sum of a number and 7. The sum of a number and a negative 7. So you see how they've worded that with the sum of a number and a negative 7. It says 7 greater than a number, and that's where you just go n plus 7, which is basically the same thing, and then the number increased by 7. So all those phrases basically mean the same exact thing. They gave you one with a negative 7 value and put in parentheses to show you. Then they give you similar word phrases with subtraction. 7 less than a number, and remember that order matters in subtraction. Order doesn't necessarily matter in addition. So if you got it backwards on the top half, it wouldn't matter because 3 plus 4 is the same as 4 plus 3, okay? But if you get it backwards in these subtraction ones, you're actually going to be wrong because 3 minus 4 is not the same as 4 minus 3. So, but you can look through those. 7 less than a number decreased by 7. The word product we know means multiplication. So it says the product, this is page 270 now, of a number and 7, so it's just 7n. Twice a number is 2n. 9 times the opposite of a number, that's a little bit tougher, but you put the parenthesis there because a number outside of a parenthesis invokes the operation of multiplication. And the opposite of a number is where you get the negative, because we learned that the word opposite, the subtraction sign, the negative sign, does simply just mean the opposite, as we learned 4 or 5 lessons ago. And then we get to more complex ones as you get down. The sum of a twice a number and a negative 8. So you got to put the sum in there, which is a plus sign. The sum of twice a number, so that's 2n, and a negative 8. So sum is plus, so you have to put negative 8 this way. And again, I've told you before that we're trying to not use this minus as subtraction. We want to use it as a negative as opposed to subtraction. We're trying to get away from subtraction as we segue into algebra. And so that's that one. Again, you have some more difficult ones there. Let's do a couple of those. Let's do the bottom 2. It says 4 times the sum of twice a number and a negative 3. So the 4 times has to be on the outside, as you see there from the illustration, because it's times the whole thing. So look at that one where it says, again, it says 4 times the sum of twice a number and a negative 3. So twice a number and a negative 3 is multiplied by 4, and that's how you work the problem. And you're not necessarily solving for anything right now. You're just kind of processing how the word problems work. So they said 4 times twice the number, 4 times the sum of twice the number and a negative 3. So you got to have sum right there, that's your plus. Twice the number's right there. What it's added to is a negative 3 sum negative 3 and 4 times that number, 4 bracket 2n plus negative 3. You could write it this way too, if you'd like. The reason I have this bracket here is because they have a parenthesis here. But if you write it this way, then all you have to have is a parenthesis, because the parenthesis is your first parenthesis, then you go to brackets after that. So you work out from inside out on parentheses. All right, so A, B, and C, you could go ahead and pause. You could try to do those 3, and they're right there, similar to you. So the sum of a number and a negative 4, quickly put, is a number plus a negative 4. That's A. Did you pause and try to do it on your own? I hope you did. And let's go a number reduced by 4. That's just n minus 4. Pretty self-explanatory on that. B, a number reduced by 4. And it says the sum of the opposite of a number and a negative 3. So we have to have a sum. The opposite of a number is going to be negative n and a negative 3. So it'll look like that. This is letter C. So it says the sum of the opposite of a number and a negative 3. So again, that's just something you're going to have to process through, and it's not going to come easy. I'd read through those, and as you get to your lessons, you can figure those things out. So let's go on to lesson 87. Our target is lesson 89. Let me make sure I still have volume here, because I'd hate to run out of volume and you not be able to hear me. That would be terrible. The associative property, reflexive property, the symmetric property, and the transitive property. They're going to give you the commutative property and the associative property here today that you're going to learn. And basically what they're wanting you to do here, this is not too terribly difficult. They're wanting you to start realizing that in addition and multiplication, order does not matter. What that means is this. If it makes it easier to add something or multiply something a different way, it's, I'll give you the example on 87.1. It says 87 plus 49, and you might want to start committing to memory all these properties because they come back up, and you might have to refresh your memory. But right here we're using the commutative property and the associative property of addition. So they have this. Now, I can't do that in my head if I go 87 plus 49 plus 13 plus 51. But I know order doesn't matter in addition. So I can add these in any order. I'll just give you a very simple example. 2 plus 1 plus 2 plus 1. Okay? I can go 2 plus 1 is 3, plus 2 is 5, plus 1 is 6, right? Or I could do this. I know that 1 and 1 is 2, and 2 is 6. So the order doesn't matter. If I go 2 plus 1 is 3, and 2 plus 1 is 3, if I make this 3 plus 3, I get the answer 6. So with that in mind, what I'm doing here is I'm seeing this 87 and this 13. And in my mind I'm thinking a 7 and a 3 will end up with like 10. So 8, 9, 10. So 87 plus 13 is going to equal 100. So I'm doing this in my mind now. I don't have to add all these up. I don't have to do 87 plus 49 plus 13 plus 51, 7, 16, 19, 20, 8, 9, 10, and so on and so forth. I don't have to do that. That's too much work. I'm going, in my mind, that's got to be 100. And 49 and 51 together, that's like 50 and 50, right? And that's 100 also. So in my mind, I'm saying 100 plus 100, that's 200, right? So instead of trying to add all those up the hard way, I'm just saying to myself, the commutative property of addition is telling me I can add in any order. So I'm going to add the 13 to the 87 because I know it's going to give me a very easy number to work with, around 100. I'm also going to add the 49 to the 51 because that's also going to give me a very round number, which also is 100. And I can do 100 plus 100 in my brain. So I can add all this up in my brain by using the commutative property of addition. So that's what they're trying to convey to you in lesson 87. And you can do those in any order. They've actually separated them like this. And that's kind of where the associative property comes in with the parentheses there. Doesn't really matter. You're adding them anyways together. And I've done it, in my mind, a little more simpler. 87 and 13, I'm just putting little arrows to connect those. The 49 and the 51, the arrows to connect those as well. Alrighty, let's do practice A. Pause it. This time it's multiplication. I want you to do the same kind of thing, okay? Make sure my thing's going well. Oh, it's buffering a little bit. Sorry about that. Not sure why it's doing that. All right. It looks like I got a little bit of tracers there. I'm not sure why. And Samuel, can you check the upload speed right now? Because it looks like there's a little bit of those tracer things we get sometimes on Wednesday nights. I didn't mean to yell at you guys. Letter B. I'm sorry, letter A. Okay. So in my mind, I'm thinking to myself, that's going to be 100, because 5 times 20 is 100, and 25 times 4 is also 100. Do you know how to do that? You can do it on your phone too if you want to. Or you can switch off that if you need to, or just put it like Apple New, and then just put upload speed. And I want you to keep that on though, so don't get rid of that. All right, I was talking. It might be causing it. That's the only thing. Oh, really? Yeah. Well, should we just turn that off then? Yeah, probably. Okay. Let me show you something real quick. When you have hundreds here, when you multiply by zeros, all you got to do is count the number of zeros. 1, 2, 3, 4. 1, 2, 3, 4. 1 times 1 is 1, 10,000. So letter A is 5 times 25 times 20 times 4. I could do that left to right if I want to in order, or I could use that a commutative and associative property and be creative in that. And 5 times 20 is 100, 25 times 4 is 100, 100 times 100 is 10,000. And again, you can do this in your head that way. I could go 25 times 5 equals 125 times 20 equals 0, 0, 4, 5, 2,500. 2,500 times 4 equals 0, 0, 0. 4 times 2 is 8 plus 2 is 10, 10,000. I could do that and get to 10,000, or I could just in my head go 5 times 20 is 100, 25 times 4 is 100, 100 times 100 is 1, 2, 3, 4 zeros. That's 10,000. Okay? So, alrighty. Let's go on to, let's do this. Let me do a couple problems on this particular lesson, and you can do the odd ones as homework, and that way you can, I'll do 21 for you, and it goes like this. I'm actually doing some of your work for you. Thank you, Mr. Soto. Very nice of you, Mr. Soto. I'm there for you. I am very sad that we can't congregate like we normally do on Tuesdays and Thursdays. Other than Landis, he never comes on Thursdays, but that's okay. And so here, this is something we learned 3 or 4 weeks ago. I'm just reviewing this. This is number 21 on lesson 87. And so, again, what you have when you have this equal sign here, you can create that butterfly or Band-Aid or Flutterby technique, and you just cross-multiply to solve for x. Okay, so here you have 4 and 1/5 x equals, because x times 4 and 1/5 is 4 and 1/5 x. Here, the best thing to do, you're going to have to convert it to an improper fraction anyways. So we're going to turn this into an improper fraction right from the start. 3 times 2 is 6 plus 1 is 7. And 2 is our denominator, so we put 2. 1 times 8 is 8 plus 1 is 9. Okay, so I have 3.5 times 1 1/8. And I could also turn this into an improper fraction as well. 4 times 5 is 20 plus 1 is 21, so we'll call it 21 over 5. All right, so I turned everything into an improper fraction. I cross-multiplied. I got to see if there's anything I can reduce here. And I don't think I can. All righty, so what I'm going to do is I'm going to multiply 7 times 9, which is 63. 8 times 2, which is 16. So I have 21 and 5x equals 63 over 16. Now here when you have this fraction outside an x, you do its reciprocal right from the start. So you go 5 times 21. 5 times 21. And this will cancel out. I got x now all by itself. And I know I can reduce this because I know 7 is going to go into both of those numbers. So 7 goes into 21 3 times. 7 goes into 63 9 times. And let me see if there's anything else I can reduce. Doesn't look like I can. Oh, I can. Absolutely. 1 3. So 21 actually goes into 63. I should have seen that. Me apologies. Sometimes you reduce by not enough and you just keep reducing, which is fine. So now what I'm going to do is I'll multiply 3 times 5 is 15. 16 times 1 is 16. And there's my answer. X equals 15 over 16. So I did one of your work for you. Just remind you how to do it. And that was number 21 on page number 274. And let's do number 27 also, because Mr. Soto is the nicest teacher you've ever had. And so let's do this. I could wall away the hours. La ta 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 ta. La ta 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 ta. La ta ta. I could be another Lincoln if I only had a brain. We're going to use the word evaluate here. Remember, evaluate is different than solving. When you solve, you have an equal sign. Here, there is no equal sign. They have x plus x, y. They do give you values for each of these, so you're not solving for these. You're actually going to substitute these in. This is number 27. And you have x equals a negative 1, y equals a negative 9. So now what you do is you take these values that they've given you, you evaluate, or you plug in the values. So now we're going to take this x and make it negative 1 because that's what it says. We'll leave that plus sign there. Let's do it like that because we want to not confuse our minus signs that are there. So x has a value of negative 1. Y has a value of a negative 9. So now what I'm going to do is I'm going to go negative 1 times a negative 9 is a positive 9 plus negative 1 because I got to multiply order of operation before I add. So I have a negative 1 plus 9, and my answer is 8. I've evaluated it 8. Again, I want to try to avoid using the equals 8 because we're not solving. We just want to say the value is, or we've evaluated to 8. And so that's number 27. Again, they gave you this problem. They gave you these values. You plug in those values. Then you evaluate with those values, and you come to a number that you've reduced that to. All right, let's go on to page number 275. And we're going to do this one and one more. That's 6 lessons. That is a week and a half's worth of work. You'll get another 6 lessons in about a week or so, maybe a week and a half. And that way you'll have 12 lessons total. Hopefully we'll be back to class in April. If not, we'll do the same thing for the last 3 weeks of school. Stick with us. I want to finish through this. We'll have 12 more lessons after this set of 6 and the next set of 6, and then 12 more, and should get us right to where we need to be. And so page 275 is where we are now. And surface area. Let me grab this box here. Don't go nowhere. I know don't go nowhere is a double negative, and I shouldn't use those because 2 negatives equal a positive in math and English. But sometimes I use double negatives just for emphasis sake. This here is a box of Kleenex. We have these in our building here. Okay, volume is what it would take to fill this up. We're not talking about volume, though, now. We're actually going to be talking about surface area. So we know area is what, like one surface. The area of this is length times width, right? But it's got 6 sides to it. And there's 3 sets of 2, because this side is the exact same as this side, that side is the same as that side, and the bottom and the top are the same. So it's got 6 sides. It's a cube, not a full cube, but it's cubesque in its form. And so this and this are the same, so you can figure those 2 out by adding them together. Once you figure out one, you have the other. This and this, this and this. So you have to length times width times 2 would be the next side, plus length times width, and double that because of the 2 sides, length times width, and that might be a perfect square there, so on that end. So we're doing surface area, but we'll do a little more complicated here. So let's look at 88.1. It's got this little triangle-looking thing there. And I'll draw these little imaginary lines. So this is basically like oblongated triangle. Almost like if I'd taken this and just kind of smashed down one side and made it like a right solid. That's what they're calling that. So they've given me 4, 5, and 3 for you parents at home. You'll notice a little Pythagorean there, won't you? And with the 3, 4, and 5 in the right triangle. And so we basically have 5 total sides. Okay, the end of this one and the end of that one are going to be exactly the same. Then you have 1, 2, 3, and of the actual oblongated sides. And they said that that's 16 going down. So there's a couple different ways you can do this. And first let's do the end caps. And we'll have side 1, 2, then we'll do 3, 4, and 5. We'll lump those together. So let's put 1 and 2 together, okay? So we know it's half the base times the height for the area of a triangle. So area of a triangle equals half the base times the height, okay? So 3 times 4 is 12. Half of 12 is 6. So this is 6 here. If this is 6, then we know this is 6, and 6 plus 6 is 12. So the two end caps is 12, and they're meters, and they're squared because area is always in square units. So it's 12 square meters. If I could cut this open, I could actually turn it into like a long rectangle, right? If I took a sheet of paper and I folded it in a couple different spots, for example, let me see if I got a sheet of paper here. So I've taken this sheet of paper and I'm going to fold it. And can you see I'm making a triangle out of that sheet of paper? And so if I open it up, I can make a rectangle out of it, right? So I have 3, 4, and 5. So let's just go 3, 4, and 5. And this is actually a long rectangle. The area of a rectangle equals length times width. So I can lump 3, 4, and 5 together by doing this. 3 plus 4 is 7, plus 5 is 12. 12 times 16, not to scale. 6 times 2 is 12, 6, 7, 0, 1, 2, 2, 9, 192. Does that look right? 12 times 16, it's been a long day. Yeah, that looks right. So 192, so this is 192 here, meters squared. So I've got the end caps are 6 and 6, which is 12. That's side 1 and side 2. And then 3, 4, and 5, I could actually go 3 times 16 plus 4 times 16 plus 5 times 16. A little easier to do it this way, though. I get 192. I can add those up. And when you add up, values got to be the same, and your unknown measurements or the known measurements and exponents all stay the same. So it's 204 meters squared should be your answer. Should we turn the page and see if I got it right? Let's do that. All right. Oh my goodness. 204 meters squared. Nice. Okay, so 88.2, a little bit tougher. Let's look at this shape here. Let's read what they want, and then we'll see if we can figure out this one. Okay, find the lateral surface area of this right solid whose base is shown in the figures. And so we have this little, these are rights. Let's put those little squares there, and they give us 8 and 8. And the radius I should say, radii is plural, of that half circle is 3. So what we have to do is we have to do this. We can actually, if you want to, open this thing up. For example, let's just say I have this, and I've turned this piece of paper into this shape that we have there. So let's see if I can make it look a little bit like that. Feels like a bullet, right? Looking like. So if you can see that there, I've kind of taken this, and if I can turn this like this and open it up, I can find the lateral surface area. Okay? So let's do that. And if this is 3 and it's the radius of the half circle, we know that this is going to be 3 also, and that this is going to be 3. And since this is a rectangle, we know that that's going to be 6, right? Because the radius is 3, so that all radii of a circle are equal to each other. And so 3 and 3, so we know this is 6. So we have 6 plus 8 plus 8 plus this measurement here. So we got to find out that measurement, okay? So let's do this. Circumference of a circle is pi times the diameter, okay? So the diameter is 6, but since this is a half circle, you have to cut it in half. You could then, in essence, just use the radius. But for keeping consistent, I'm going to do it the longer way because I think that's a better way to do it for your sake. Okay, so circumference is the measurement from here to here on this half circle. So I have pi, we'll use 3.14 because that's a standardized measurement of pi. Diameter is 6, but I have to divide it by 2 because it's going to be a half circle. Okay, and again, I could reduce that to a 3 right now. I'm not going to do that. I'll divide it by 2 at the end, but I would strongly recommend you doing it that way moving forward, but I don't want to confuse you. So 3.14 times 6, let's do that. 6, 7, 8, 18.84 divided by 2. So we have 18.84 divided by 2 because it's this times this divided by that. So that's going to be 9.42 if my math's correct. 2 goes into 18 9 times, 2 goes into 8 4 times, 2 goes into 4 2 times. So the measurement from here to here using circumference equals pi times diameter divided by 2 is 9.42. So I have this, 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 and this. Let's add all those up. 8 and 8 is 16, plus 6 is 22. 22 plus 9.42. You can keep the decimals added up, obviously. 42. This is 11. That's 31.42. And they told us that it's 10 feet tall. So we have to also now multiply it by 10 because the whole thing is 10 feet tall. And so that's times 10. Anytime you multiply by 10, you're actually just moving the decimal one time over, right? We learned that already. So let's just move that one time over like that. So now the surface area of this figure in 88.2 is going to be 314.2, and it's feet, and it's squared. So there's your answer. Hope that made sense. And practice A. Do the same thing, unfold that dude, and then multiply it by the height. And you'll find the surface area of that particular. Why don't you try it? And I'm going to do it on the board. So pause for a while, and you're going to try practice A. Pause it. Why are you want me to do all your work for you? That's what I'm saying. All right. I'm only kidding, by the way, parents. I'm really nice. I just jokingly joke sometimes. That's pretty easy, actually. 4, 4, 4, 3, 3. Just add all those dudes up and multiply by 40. So 4 and 4 and 4 is 12. 12 plus 6 is 18. 40, I'll put that on the bottom because it put the 0 there. It's 720 meters squared. There's your answer on practice A. All right, let's go on to lesson 89. This will be the last one that we're doing today. I might do a couple problems for you. And all right. This is actually going to take you some thinking time, so I need you to just go get a drink of water, press pause, get a snack. Little bit, I'm going to challenge your thinking here for a second. All right, so press pause. All right, here we're back. So I want you to look at 89.1. They want you to graph this right here, and it says x is not less than 2. I have to sneeze here real quick. Promise I don't have any coronavirus. I tried to cover the mic there so I didn't sneeze into your eardrums. Now, when we get these comparative greater than, less than, or signs, there's lots of answers that satisfy the inequality. We call those inequalities. You'll use those, as a matter of fact, in algebra we'll learn about inequalities right now. So it's important for you to this will be something you're going to learn and have later in math as well. All of this is, but some more so than others. Let me show you a couple things real quick, and then we'll get into this problem. If I say x equals 2, there's only one value, and that's going to be 2, because 2 is equal to 2. Equals means same